Welcome back. We are still on the series Set Theory. Now we'll be looking at the Venn diagram. Venn diagram is simply the pictorial representation of sets. Now it was invented by a mathematician called John Venn, and we are going to be using Venn diagram to show the relationship between sets, which is the union of sets, complement of sets, intersection of sets, and so on. So that's where we are going. Now, what John Venn did was that he used circles to represent subsets, and then he used a rectangle to represent the universal set. So these are the subset of the universal set. This is set A and this is set B. Now the union sets, he used the rectangle to represent. So the circles here represent the subset of this universal set. So we are going to look at intersection, union, complement using the Venn diagram. At the end of the day, we will look at it for both 2 Venn diagram and 3 Venn diagram, after which we will apply it to solve real life problems. Okay. So let me go back to this. If I have a set which is a universal set, say 1, 2, 3, 4, and 5. This is a universal set. Then if I have a subset A to be equals to, I pick some elements of the universal set, say 1 and 3. And then I have set B to be maybe 1 and 5. Okay. I want to find A intersection B. You know, A intersection B means the element that is common to both set A and set B. That's in our previous video we looked at relationship between sets, and we look at intersection. So we say that the intersection of 2 sets A and B are those elements that are common to both sets, and the only element common to both sets here is 1. So A intersection B is 1. Okay, now let's show this intersection in the Venn diagram. Now in the Venn diagram, if this is set A and this is set B, so this is the universal set. The universal set, this is set A and this is set B. So we say that A intersection B is 1. So this is the point where A and B intersect. That means that that element here, 1, will be here. 1, that's A intersection B. So in Venn diagram, we're interested in the shaded region. So that means if I shade this region, what I am talking about is intersection of these 2 sets A and B. And of course, that shaded region is where we have the element 1. Alright, let me find A union B. A union B simply means bring the element of these 2 sets together without repeating the element. So I have 1, I have 3, and I have 5. I have 1, 3, and 5. That is the union of the 2 sets. Now, if I'm representing it on the Venn diagram, this is set A and this is set B. So if I have this, okay, before then, let me write this. So this is A intersection B. It means that the shaded region is A intersection B. But for this one, union means that the element is common to both sets, and also to, okay, it's common to set A, it's also common to set B, and it's also common to both sets. So this is A union B, 1, 3, and 5. But you know, if you want to find the union of the union of these sets, 1 is common here, 1 is common here, which is intersection. So look at the 1 here. So if 1 is common and 1 is common, and I pick it out, in set A, what is left will be 3. Look at the 3 here. What is left in B, having picked out 1, is 5. So look at the 5 here. So there's elements in the intersection region, There's an element in set A, there's also an element in set B, which is 1, 3, and 5. That's what we have, a 1, 3, and 5. So in union, we shade everything, including the intersection region, and then set B only. We shade everything. So the shaded portion is where we are interested in, which is A union B. All right. Now, if I have something like this, which is set A and set B, this is A, this is B, this is the universal set, and I shade this place alone, just set A alone. That is what I have shaded. How do we write this? Okay, very simple. Now you can see that the element A is found only in set A, but it's not in set B. So you can see with me that there is no element in set B. Now the question is, those elements that are not in set B, where are they?
Mathematics tutorial with Emma Johnny.